بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الاستاتيكا، ويعتبر آخر درس في مادة الاستاتيكا، واسمه الكتلة السالبة. وناس تسأل كتير، هو في كتلة سالبة؟ الكتلة السالبة معناها إن إحنا بناخد الدرس ده بعد مركز الثقل. ففي أي جسم بيبقى له مركز ثقل، لكن لو الجسم ده اقتطع منه جزء، فالجزء اللي اقتطع منه ده بنسميه الكتلة السالبة. وأكيد طبعا مركز الثقل بيتغير من الحالة الأولى بعد الانفصال الجزء المقتطع. Welcome my dear student in our math program for second 3. Today we are taking new lesson in static. It's called the mass or negative mass of the center of gravity. My dear student, look at the negative mass of the center of gravity of the body. Math or negative mass method, my dear student, look at the first example. The first example, a uniform lamina ABCD in the form of rectangle of mass 24 gram. Remember, my dear student, we have uniform lamina ABCD in the form rectangle. My dear student, if we have lamina a shaped uniform rectangle, then the center of gravity lie on the center of its diagonal. Excellent, student. This lamina, its mass 24 gram, in which AB 11 centimeter, BC 14 centimeter, E and F are midpoints of AB and AD respectively. The triangle AEF is cut off or separated, and the mass 1.5, 3, 4.5 gram are fixed at point B, C, and D respectively. Determine the center of gravity of the system. Then, my dear student, if the system is suspended freely C, prove that the side CV is inclined to vertical with an angle of measure 45 degrees in equilibrium position. Solution. My dear student, look at ABCD as a rectangle. Point G2 is the center of gravity, it's the intersection of two diagonal. My dear student, look at, if we divide it, the mass of EAF over the mass of rectangle, we find that area of triangle over area of rectangle. What you deduce? Mass of triangle over mass of rectangle equal the ratio between area of triangle over ratio of rectangle. My dear student, mass of triangle EAF over 24 mass of rectangle equal half base times height area of a triangle over what? 11 times 14 area of a rectangle. Therefore, my dear student, the mass of triangle EAF equal 3 gram. My dear student, in this example, we have rectangle and triangle is separated from a rectangle. There is relation between the mass of triangle and the mass of a rectangle and the area of each one. What is the rule? Mass of a triangle over mass of a rectangle equals area of a triangle over area of a rectangle. There is proportion between two mass and two areas. My dear student, in this example, we have not mass of a triangle which separated or which cut off, then we deduce the mass of triangle by using cross multiplication to find the mass of a triangle which cut off. My dear student, we are follow the solution. The mass of a triangle EAF equals 3 grams. My dear student, let CX and CY be two perpendicular directions. Distance of the center of gravity of triangle EAF and CD straight line equals x1 plus x2 plus x3 over 3, 35 over 3, and distance of the center of gravity of triangle EAF and CB straight line equal 5.5 plus 11 over 3 equals what? 27.5 over 3 centimeter. Then we form the table of mass and their coordinates as follows. My dear student, G1, B, C, D, and G2. Mass -3, 1.5, 3, 4.5, 24. X coordinate 35 over 3, 14, 0, 0, and 7. Y coordinate 27.5 over 3, 0, 0, 11, and 5.5. My dear student, remember the origin point at point C, 0, 0. X coordinate, Y coordinate, 0, 0. By using the rule, find the value of xg equals what? Equals 77 over 15. Also yg by the same method equals 77 over 15. Then two coordinate equals, look at my dear student, the center of gravity of the system G 77 over 15 and 77 over 15. What did you deduce? Two coordinate equal coordinate of x equal coordinate of y. My dear student, when draw CG ray to be vertical line in triangle GKC. Look at GKC. The angle theta, when to find measure angle theta, tan theta opposite over adjacent. GK over CK. Look at my dear student, tan theta GK over KC equals what? Equals 1. What you deduce? Theta equals shift tan 1 equals 45 degrees. Then we deduce CB straight line is inclined to vertical by an angle of measure 45 degrees. Now maybe another one solved by other solution. Replace the removed triangle by 3 equal negative math, each of magnitude 1 gram. Placed at vertices A, E, and F. Then complete the solution. Now, my dear student, we translate to the center of gravity of some symmetric bodies. My dear student, look at in the opposite figure. My dear student, let A be axis of symmetry of a fine lamina. It divides the lamina into two identical parts, so their mass are equal. Let G1 and G2 centers of gravity of each part. It is above the Z symmetric axis bisects G1, G2 and perpendicular to it. That it is the two mass at G1, G2 are equal. So their center of gravity at the midpoint of G1, G2 line segment. The center of gravity of lamina is G. Is the same the center of gravity of each two identical parts. My dear student, G must be longest axis of symmetry. That means for any fine lamina of uniform, if it has axis of symmetry. So its center of gravity must be on this axis. My dear student, in the opposite figure, we have plane X, symmetric plane of the solid. We have solid and plane, plane symmetric of the solid. So divides the solid into two identical parts. Also, we assume that G1 and G2 are the center of gravity of each part respectively. Symmetric plane X divided G1, G2 line segment at point G, which is midpoint of G1, G2, and so G belongs to the plane X. That means for any body of uniform density, if it has axis of symmetry, so its center of gravity must be on this plane. Now we are translate to important title is called special cases for the center of gravity. Number one, the center of gravity, my dear student, of a wire of uniform density in the form a circle lies at X and student, it's a center. Number two, center of gravity of lamina of uniform density in the form of circle lies on its center. Number three, center of gravity of a spherical crust cortex on uniform density lies at its center. Number four, the center of gravity of the solid sphere of uniform density lies at its center. Number five, the center of gravity of a solid sphere of uniform density in the form of cuboids lies at geometric circle. Number six, the center of gravity of large circular cylinder crust of uniform density lies on midpoint of altitudes join the centers of each base. Remember, altitude means height. Number seven, the center of gravity of a large circular cylinder of uniform density lies at midpoint of altitude join the center of its bases. Number eight, the center of gravity of uniform raised prism lies at midpoint of axis parallel to its lateral edges and passing through the two centers of gravity of each two bases. Consider them as two fine lamina of uniform densities. Now, my dear student, we are translate to important example. A fine lamina of uniform density in the form circular disc. Its radius length 10 cm, smaller disc, circular of radius length 4 cm, cut off such that it touch the original disc. Find the position of the center of gravity of remaining part. If the remaining is freely suspended from one of these endpoints of the diameter of its diameter of the disk perpendicular to the line of the center. Then find, in case of equilibrium, tangent or tangent of the angle between the line of centers and the vertical. Remember, my dear student, find in the case of equilibrium tangent of the angle between the line of centers and the vertical. Solution. My dear student, look at the bigger disk as a circle, the smaller disk also a circle touch internally. Remember, my dear student, in this case, area of a circle of bigger over area of smaller circle equals mass 1 over mass 2. There is proportion between two areas and two mass. My dear student, determine the mass of gravity remaining part, mass of original disk over mass of removed disk equal area of the one, area of the first over area of the second equals 25 over 4. If the mass of the first 25 m, then the mass of the removing is 4 m gram. The mass of the original 25 m act at G1. My dear student, mass of the removed disk negative 4. Why negative? Is removed or cut off. Acts at G2. Then from previous that G1, G2 is an axis of symmetry of the figure. G1, G2, the center of gravity of remaining part must lies on G1, G2, axis of symmetry. So choose that Cx and Cy to be perpendicular direction and form the following table. Mass, we have two mass, 25 m, negative 4 m. We have x coordinate only 10 and 16. Therefore, by using xg, 25 m times 10, negative 4 m times 16 over 25 plus negative 4 m xg must be equal to what? 8 and 6 over 7. G is center of gravity of the remaining part and it's a distance. We subtract 10 from 8, 6 over 7 from 10. Answer is 1 and 1 over 7 centimeter. From the sun, from what? From the center of gravity of original disk G1. Second, when the lamina suspended from E, join EG to be vertical line passing through the suspension point. Look at, my dear student, vertical line EG. What is the measure angle theta? In triangle EG G1. Look at triangle EG G1. Tan theta equals EG1 over GG1. EG1 is radius. EG1 equals 10. Why? Radius. GG1 equals 1 and 1 over 7. Then equals 8 over 7. We find tan theta by using 35 over 4, this tan theta. Now, my dear student, translate to another example. Find lamina of a uniform thickness and density and its mass 4m in the form of rectangle ABCD. AB8, BC12. Its diagonals are joined intersection at point E. Then triangle ABE is removed. Mass of magnitude M, 2m, m placed at vertices A, C, D, E respectively. Determine the center of gravity of the system, and if the system is freely suspended from D, prove that in case of equilibrium that the vertical line passing through suspension point bisects angle ADC. Solution. My dear student, look at ABCD is a rectangle. Determine the center of gravity of the system. Mass of triangle EAB. Look at EAB, quarter of mass of rectangle lamina equals M, and act at G1. The mass of rectangle lamina equals M and acts at G1 and its negative mass. Then fix some masses at vertices A, C, D, and E. My dear student, choose the two perpendicular directions DA and DC. The point of intersection of medians of triangle BAE equals x1 plus x2 plus x3 over 3, also y1 plus y2 plus y3 over 3. Its coordinates became 10, 4. And to form the following table, at G1, at E, at A, at D, at C. Mass is negative M, 5M, 5M, M, 2M. X coordinate 10, 6, 12, 0, 0. Y coordinate 4, 4, 0, 0, 8. Find XG by using the table. From the table, find the value of xg equal 4, also yg by the same method equals 4. Then we deduce that center of gravity of the system 4, 4. My dear student, vertical line make angle theta with DA. As suspended from D, my dear student, and triangle GND tan theta equals GN over DN equals 1. Then measure angle theta equal 45. We deduce that the vertical line passing through D bisects angle ADC. My dear student, now we are translate to another example. Look at, my dear student, we have four mass magnitudes 1, 2, 4, 5 grams are fixed at point A, B, C, and D respectively on a broken line ABCD as shown in the opposite figure. Look at CD perpendicular to AB, measure angle ABC 120 degrees, find the center of mass of gravity of the system. Solution. Look at, my dear student, this is ABCD, angle ABC 120, AB equals 6, BC equals 12. We have measure CBD equals 60. Why? Because measure angle ABC 120, then measure CBD 180 minus 120 equals 60 degrees. Measure angle BCD equals 30 degrees. Also, BD equal half, BC equals 6 centimeter. My dear student, DC equals 6 root 3 centimeter. We have BD have PC. Why? Because measure C equals what? Equals 30. BD, opposite angle 30, half length of BC. Then BD equals 6 centimeter. Then what is the DC? By using Pythagoras theorem, 12 power 2 minus 6 power 2 under square root, or by using CD equals BC sine angle CBD or sine 60. My dear student, let AX, AY are two orthogonal directions as shown in the figure, then form the table for mass and their coordinate as follows. Look at, my dear student, AX, AY represent x-axis and y-axis. We have mass 1 gram at A, 2 gram at B, 5 gram at D, also 4 gram at C. We form table. Table, we have 4 vertices, A, B, C, D, and D. What is the mass? At A equals 1, at B 2, at C 4, at D 5. What is the x coordinate? At A 0, at B 6, at C 12, at D 12. Y coordinate? At A 0, at B 0, at C 6 root 3, at D 0. What is the xg, my dear student? xg m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 over sum of 4 mass. Therefore, xg equals what? Equals 10. 120 over 12 equals 10 centimeter. Also, by the same method, yg m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 over m1 plus m2 plus m3 plus m4. Then the value of yg equals what? 24 root 3 over 12. Now we reduce that to root 3. Therefore, the center of gravity G 10, 10 and 2 root 3. The center of gravity, my dear student, x coordinate 10, y coordinate 2 root 3. This center of gravity is respect to point A. By the end of the lesson, I am very happy to spend such time with you. Thank you.